Okay, it is now 2 after. We're going to go ahead and get started. We have a full agenda here and a lot to share with you. So we want to respect your time and start on time and finish on time as well. So thank you very much for joining today. This is our first Gluware webinar in a little bit, so we appreciate you tuning in. Today's title is called Rapid Automation of Your Existing Network. And we're going to dive into a lot of details to show you how to accomplish that. And there you can post questions. We'll certainly try to look at those as we go, and we have a little bit of time at the end to address that. We won't be doing polling, so you don't have to worry about that. With that, let's get going here. On today's session, we have two presenters, myself, Michael Howe, VP of Product Management from Gluware, and Julie Whaling, a solution architect based out of St. Louis. A very quick background on the two of us. I lead product management and marketing for Gluware with over 20 years in networking experience, starting my career at AT&T in operations and engineering and moving on into, I started my career at IBM. My division was sold to AT&T. It's kind of a blur for me now because it's almost 20 years ago. But that's the time when I really honed my skills, becoming an expert in routing and switching, and achieved my CCIE back in 1996. So I really date myself there, but I have lived the pain of manually configuring networks and trying to automate back in those days with Tickle and Expect and other tools. Julie's, as I mentioned, is based out of St. Louis and also brings a wealth of experience with roles in system engineering and network design, network architecture, and cloud architecture as well. Julie's also worked at AT&T and Southwest Bell Communications. It's funny, when you look at technology people, usually you have a carrier or you have an equipment manufacturer on the resume. It just is part of the gig there. And she's also pursued Cisco certifications, including achieving her CCNP, among others. Also holds a BS in computer science and a master's in telecommunication management. So let's get into the meat. When you think about network automation, those of us who know networking know the one word that goes along with it: complexity. And really, that's the hallmark of why it's difficult to automate. Is there's a lot of underlying complexity. You have multiple vendors. Even if you've stayed with the same vendors, you have products that have gone to the network over time. So there's generational gaps and feature gaps. You're running multiple operating systems. Even again, from a same vendor, you might have 4 or 5 different product lines, each with different operating systems. And even within the same operating systems, sometimes from one version to the next, syntax and things change. You have device types like routers, switches, firewalls, WAN optimizers, load balancers, wireless LAN controllers, and others. And you're always under the gun to look at and deal with things like security patches and operating system updates. This has become a real pain point as vulnerabilities and outages and hacks become mainstream news and embarrass companies and become liabilities. You also have disparate policies. You have policies that have been developed over time, policies that are paper policies that are not actually enforced on the network, because there is that disconnect from what we think is on the network or what has been defined, what should be on the network, and what is reality. So we like to ask the question, what if you were able to achieve the gains that our customers have actually demonstrated, which are things like gaining efficiencies of 98% reductions in terms of global changes, in terms of the amount of time it takes that. When you look at time to roll things out manually and scheduling those hours versus automating changes, and these data points are taken directly from customers. Enhancing security is on the top of everyone's list, with customers having goals of being able to update or patch the network on a monthly basis. We hear stories all the time about how networks of old or networking equipment goes in and you don't touch that operating system and then you're pulling out that piece of equipment 5 or 10 years later. That has changed with, again, the hacks and the vulnerabilities. Now operations is really pressured to look at those security advisories and keep up with updates to protect the network. And finally, agility. It's all about keeping up with the business demands and actually being able to achieve network changes that keep the pace of the business. So what if you could complete global changes within 24 hours of that request? So these are some realities that Gluware customers are achieving. So this is kind of stereotypical when you join a webinar and you get the research slides, but What I want to point out is this is very recent research. EMA did this study just and produced the results just in September of this year. Gluware was the co-sponsor of this report. It is on the topic of enterprise network automation for 2020 and beyond. And those of you who attend or at least registered for this webinar, we will send you a link to download the full report. But usually when Gluware engages with a prospect looking to automate, we want to understand what are the needs, what are the outcomes you're looking for. And I think this list, some of these things would may not surprise you, but I think one thing that kind of does surprise some people, and we hear it frequently as the top thing, is reducing risk. It's using automation to enhance security and keep the network compliant. It could be to internal standards or external standards, but if you're able to lock down the network and keep it compliant, you really reduce the risk and ultimately reduce outages. And when you're talking to financial networks, that the network is, those transactions are the business, or stock traders, in terms of financial transactions, or retailers that require the point of sale equipment to be working over the network. Almost every critical function these days runs over the network in some form or another. So it's point two, and I'm not going to go through all of them, but I want to go through the top 3 or 4 that we keep hearing. Elimination of human error. And I find this actually to be a 2-part factor, which is, yes, we ask engineers to stay up very late nights, work those windows, and make changes to network devices. And when you're cycling through these network changes, and if your tools are Notepad and copy paste, you're bound to make an error, right? Or you're bound to fat finger a command because we hear this all the time. Engineers are working these off hours, and error just happens. Even the best of us, it happens to. And what if you could eliminate that, right? Really, allow your engineer to design the change and then have it automated on the implementation. The other factor you get with that is time. That engineer's time in working those long hours and the time it makes to make those changes, if you can automate those things, it's actually really a win-win. The third one, a big one we hear a lot, is the proactive problem detection. Really is getting ahead of, before the ticket comes in or someone's complaining. We were at a customer recently where a network outage caused their folks who work a call center to just be sitting there because their phones aren't ringing because the network's affecting the voice over IP network. So problem detection and resolving problems before it has boiled up to become something visible to the end users. And I'll jump to the fourth one, which is back to agility and responsiveness to change. And what I find is, in networking, you have these 2 opposing forces. You want to reduce risk and keep things stable, but then again, you want agility and you want to be making changes very rapidly. And the way to balance those forces is really through automation. So again, the other one I'll touch on real quickly is reduce staff count. We actually never hear that. We do hear, let my team work on more important tasks than some of the low-level things they're doing when they're not automating. The other thing we do here is reducing outsourcing, some of the outsourcing dollars and time. So those do factor into headcount, but certainly people are trying to do more with the same amount of heads, and in very few cases are trying to reduce. So what is blocking them from getting to this? And these stats are interesting too, because as you dive into them, there's a lot that is under the cover of what these mean on the surface. So price, meaning it's too expensive. When you dive into that and understand why people perceive that, generally automation means you're acquiring new hardware with new software that brings you automation from that vendor. So therefore, it's greenfield, right? It's a new SD-WAN deployment. It's a new data center, software-defined data center install and upgrade. And therefore, they view it as expensive. Next is difficult to build and implement. This is very, very true, but this comes from the perception that, and it's been in the industry for several years now, is that network engineers have to become programmers. And the only way to automate is to become a Python programmer or, choose your language. And, it is a build your own type of story in building scripts and scripts that plug into frameworks. And it is difficult. It's actually very difficult to build those things that correlate and do other data points here. It's difficult to build things that are scalable and reliable. One of the things that jumped out to me in this research is that the instability or quality of the so-called tools. Many of these are the build your own tools, and it's kind of nerve-wracking when someone writes a script. If it's different if you're doing it in a lab, but if you're doing it in production and you wrote a script to go make changes across a production network, when you hit that execute button, I'm sure it's quite nerve-wracking. And what we're finding even in very large organizations, because vendor tools are coming up short, they're supplementing these with scripts, and these scripts are not highly reliable. When we've helped customers audit after running scripts, we're finding, when you look at 1,000 devices, several hundred that the script didn't execute properly. So needless to say, you guys are probably living these experiences, is that there are a lot of challenges when it comes to automation. So how do we get through that? What we're going to talk through today is we've been discussing the challenges to network automation. We have a little bit more on that topic, but to provide a framework of how to approach automation. I think it's an overwhelming thought to think, oh, I got to automate my whole network. It's going to be a 3 to 5 year project, and I have to go hire developers. When you look at the Gluware framework of what we're proposing, you can get started very quickly and start automating certain things and work up towards a fully automated environment, really kind of approaching it as a crawl, walk, run, and build upon successes to get to a fully automated approach. Next is at ONUG just a few weeks ago, we announced Gluware 3.6, so we're going to highlight a couple of those latest enhancements in our latest version of software that we've released. 2/3 of this session today are demonstrations. So we have kind of an end-to-end demonstration using Gluware, kind of a day in the life. And then we have a very specific use case that we've been helping customers with, which is deploying Network Administration Controller, NAC, on switches. I think you'll find these interesting as you look at the problem or challenge with automating complex tasks. So let's jump into this and look at how we can help bring turnkey automation to your enterprise. So as I look at the slide deck, I was really trying to cut down slides, but I really like the visualization of this, in that this is the visualization of the iceberg, and so-called the tip of the iceberg is what people have accomplished in automation today when it comes to the network. When it comes to servers and other aspects of IT delivery, things are getting automated. When you look at the network, there are limitations and things that you're running into, and all those complexities where very small, often single percent or low double-digit percent are actually automated. So what does it take to get beyond that barrier? Well, if companies take the do-it-yourself, the DIY approach, they have to build up programming skills, database skills, UI skills. There is a significant investment. And we've been talking to companies who've been down this path for a couple of years and still don't have really good results, right? Really thorough results. They haven't moved the bar that much because, again, you're asking network engineers to become programmers, or you're asking programmers to understand networking, and you're going to be hitting barriers like this. So with Gluware, one of the things that we approach is that Gluware brings all those things in a packaged format. It has the underlying databases, it has the UI, it has the notification and integrated APIs to support it. The beauty of this, though, is that Gluware doesn't view itself as the one and only tool you're going to need. That's why we support API integration with other products or even scripts that exist in your network management. So let's take a look at why is Gluware different from the things you've seen in the past. And there's network automation of 20 plus years ago that I used to use. There's vendor tools. Well, Gluware is intelligent by design, and I'm going to run through these very quickly. Certainly not read every word, but Gluware, the whole heart and soul of Gluware is the intelligent orchestration engine. This orchestration engine has the ability to read and write from the network, and when it reads in, let's say, the inventory of the routers and the switches, or reads in the configuration, it's able to dynamically wrap these in data models which enable automation. So with that intelligent orchestration engine, it has the ability to understand the CLI and semantics for each vendor and ultimately layer automation on top of them. So built off that orchestration engine are intent-based applications. So what you're going to see in the demo, and as I explain them, is that in this view towards getting towards software control, you want apps that have specific functions. So we have apps that help you with inventory and auditing and configuration management. Finally, just to touch on two other differentiating points is you're hearing about or beginning to hear about intent-based networking. And what that really means is kind of bringing a business level logic or intent that then is derived into the low-level networking commands to implement that intent with the feedback loop to then verify the network is in the right state and an ongoing basis. Gluware is very unique in this, is that most intent-based systems really kind of are built for greenfield, meaning net new. And it's a lot easier to do intent when you're net new or greenfield. When you're brownfield, meaning your network already exists, you have security policies configured, you have syslogs and NTP and other things. You don't want to start over and have something kind of wipe everything out and then redeploy your network. It's a very painful step. Gluware is actually able to derive the intent from the network as it's configured and then bring new business logic for your ongoing tasks. And some of that you're going to see. And finally, it's very scalable and reliable. And again, I got to kind of move quickly here to keep pace with covering these slides. So very quickly on Gartner, those of you who subscribe to Gartner, Gartner does a nice job of breaking down network automation and the path that we proceeded. When you look at kind of the so-called roadmap of network automation, you have the older tools, which are called network configuration change management. Then you have the bucket of tools that fall into the DevOps category. A lot of people, are under the impression that because it's working in app development and on the server infrastructure, we want to take those same tools and move them over to the network infrastructure. And we're really just seeing limited success with that. And there's a lot of reasons why, but mainly it's that complexity on the network layer. The most advanced area in networking is really this category of intent-based networking, where, as I mentioned, you bring business logic or policy, you translate that policy down to the very specific configurations you need on the network, and then there's a verification or feedback loop back to the product performing that automation to ensure you're in the right state. And Simone Ricard from Gartner at the Catalyst conference in August called Gluware out as a leader in this space, which was nice to hear. And just to mention, if you're going to be at Gartner IOCS in December, we will be there. So hope to see you there. So diving into the product, I'm going to try to annotate here and let's see how this goes. But what I want to highlight in that when you think of Gluware, it's really these components here. It's that intelligent orchestration engine, which is, again, it is a pre-built capability that means you don't have to code things. You don't have to define a database. You don't have to go learn, SQL and other languages or understand a Kafka bus and these complexities. Gluware has built the engine. And then on top of the engine are the applications that we've built on top that deliver functionality immediately. Now, all of these things are sitting on top of the network layer. So we're just pure software, and we communicate down to the network layer, primarily using SSH secure connection and emulating that user doing the CLI. Gluware is fully API compatible as well to do API calls as well. But then what do you bring to the network? One of the things you're going to see is that Gluware is a platform that enables you to bring your own policy. This is configuration policy as well as compliance policy for auditing. And that's, again, a key differentiator in the so-called brownfield, is that if you can automate your existing network, you're going to free up your network resources, your engineers, to work on the new deployments. And so we're going to talk more about that. Let me erase all this on the slide and just say that, Gluware has adapters for the network layer to enable us to read, write, and verify. And we're at 21 operating systems with our latest 3.6 release. That's 16 different vendors. So how do you consume Gluware? And this kind of ties into my comment earlier about a framework to approach automation. What we really advocate customers to do is kind of get to a known state before you start automating change. And so how do you do that? Well, first, within Gluware, there's a functionality, an app called Device Manager. Device Manager reads your network devices and creates a dynamic inventory. So we dropped in the logos here. I mentioned we're at 16 vendors. And again, the list is a little hard to maintain because some get acquired by others and all that. But when we also kind of wanted to break it out by operating system, but that gets a bit much as you get beyond 20 here. But device manager is doing that dynamic inventory to tell you what you have in your network today in real time. Building off that, we have an app called Config, Drift, and Audit. So it's a dual function app that enables you to monitor your network for change. This gives you that proactive capability to see change happening and flag it if it's an unauthorized change or something that may cause a problem. We hear frequently from customers who run this drift on their network daily that they'll see a drift and they'll know what's happened before a ticket even opens up, or if a ticket is opened, with someone having an issue, that engineer is already correlating it because he knows what changed on the network. That's a very powerful feature to enable operations with across all their devices without having to go to different tools. The audit also just as important when you're auditing for compliance standards that are standards organizations like PCI DSS and HIPAA, or if you're following some of the NIST security standards. Those audits are very important to keep your network in policy. But just as important are the ad hoc searches when you read a PCERT and something's happening, you could be exposed to it if you have configured your network in a certain way. You can draft, or you can very quickly create an on-demand audit and audit your network. So very, very powerful. That does not require any coding. So before I move forward, what I will point out is that Device Manager, Drift, and Audit, those are read-only functions. So you're automating components before you're ever taking anything that's actually going to induce possibly more risk. Building this out, you see OS Manager. OS Manager is our newest app. It actually is an update over our original OS update function, which has been in the market for more than a year and a half. And we've really revamped this to make it operational focused so you can execute operating system updates at scale and execute patches. We're very excited to show this, and because of all the features added to it, we're actually going to do a separate session. So keep a lookout. We're going to try to execute this next month in December, make it a Christmas gift, and take you through the new OS Manager in that dedicated session. Finally, config modeling, which I am going to show, and Julie is also going to show, is our approach to configuration management. We're able to deconstruct network policy into individual features and then manage those at scale. So you're going to see config modeling in action. Finally, when we talk about intent, how do you incorporate business logic? And this really kind of comes in where we're layering something called workflows. Workflows allow you to map that business intent to a network configuration or something that's done on a regular basis by your operations to go and execute. And we have workflows and design and operate and troubleshoot in different categories to assist. Finally, APIs. APIs are extremely important. When you think about the network tools that you have, the network management, network monitoring, it is very important that these tools be able to talk to each other, and that language they speak is APIs. So Gluware is able to integrate with ITSMs like ServiceNow and Remedy, and we're able to integrate with other products. So we have an announcement, which I'm going to get to in the next slide, around Ansible as well. So as soon as you have APIs, again, you can plug into other automation environments. So what's new in 3.6? Just a quick slide because there's actually a lot more than this, but these are kind of the big rocks. What I want to highlight is two categories. One's innovation and one's integrations. On the innovation side, two of these I'm going to show you today, which is around intelligent model discovery, our ability to ingest network features from the network. And then second is around state assessment, is capturing network state dynamically. And the third being OS Manager, our newest refreshed app. You're going to see that in action in our next session. A couple exciting integrations, all enabled through API. We announced a partnership with Mist, who's a Juniper company, where Mist is an intelligent wireless edge, but they don't have visibility on underlying network. When Mist detects a problem that is network related, through APIs, they can trigger a drift or audit on the Gluware to indicate if there has been a change or a policy violation on the network. With Ansible, we are just getting going really with our integration, but we're delivering an Ansible plugin to execute dynamic inventory, and we will have Ansible modules to follow. So again, Ansible is a framework and it's great, but if the so-called modules you're running on are limited, you're going to be limited by that module, and you're going to be essentially become a Python developer if you're going to need to consume that. And so Gluware's intention is to complement Ansible in terms of having intelligent network packages to run through the Ansible framework in terms of pushing a playbook or a call to Gluware. And then finally, we are continuing to enhance our RESTful API, which I will talk to. So very, very quickly, I want to just highlight a couple case studies. Mastercard and Merck are two of our, let's say, best publicly endorsed customers that we have that have given us public endorsement. Mastercard's an extremely large network, over 15,000 nodes globally, Cisco routers and switches, Checkpoint, F5, Riverbed. They're built for reliability, not agility. Back to that first point of reliability. What drove them to really seek out automation was keep the network in policy, diagnose issues faster, and then be able to be agile to deploy changes. So they're like many other companies. They have a lot of resources. They were going kind of down that DIY path, and they found a lot of the limitations. And so they were already using vendor tools and other things that were coming up short. And ultimately with Gluware, what they found was we delivered what they needed. It was packaged, it was drop-in CLI, it was declarative, which I'm going to show you in the demo. And they're able to achieve these results that are ongoing so far that we just had an update with them, where they're implementing changes within 24 hours of the request. They're on pace to get to monthly patch cycles of their operating systems. When they push changes with Gluware, they're at 0% defect rate. They're reducing their drift by 99%. And the vision here is to, again, automate these things towards, limiting all these individual manual steps that slow down the process. So very good success with Mastercard. Merck was one of our first real big customers that adopted config modeling. They are primarily a Cisco network. The key thing they drove towards Gluware was they had to migrate to Microsoft Azure for mail services and storage, and they had to essentially backhaul that traffic over the backbone, which required a QoS redesign, among other things. Gluware was the only solution they were able to find to actually automate, QoS and NetFlow and SNMP, and automate it at scale reliably. So when you look at what they're able to achieve with Gluware, we executed the whole thing, and from once they started their testing to a little over a month, really compressing that, very little skill development. We had fully the features automated. It only took like a couple of days to weeks to onboard. They still spent the time they normally spend with testing, and again, just massive compression of the schedule. And the real result, when you look at the cost avoidance, like per change, is that they were planning on outsourcing the change, which would have taken roughly 10 months. With Gluware, automating it in under a month, but they're able to actually continue to tweak those QoS parameters to ensure the applications work well and people are having a good experience using the features over the Azure cloud. So again, very, very good success. So let's switch over to a live demo. I'm going to stop sharing here and pick up sharing on my live UI, share, and let me get logged in. I mentioned already, Gluware is pure software. See if I can talk and type. I could not. Gluware is pure software. So we can either run from the cloud or run on-prem. It's multi-user and multi-tenant. I'm signed in here and I have visibility to all these different networks. I actually have a example network here called Pod 2. And in Pod 2, as I dive into the device manager where I want to perform inventory, I can see I have nothing there today. So I want to kind of walk you through day in the life using Gluware. So we're going to import a CSV file of devices. And let me just grab that file. And here we see those records were imported. So all we need from the user is a list of device names with IPs and credentials. And then with what you're able to do with Gluware is kick off a dynamic discovery. So I've executed this discovery, and you can see in parallel, Gluware is interrogating all these devices. So I'm going to double click into one of these and go into log just so you can see is that Gluware does not require anything configured on the device other than we have to be able to obviously SSH in. We then execute our device discovery library, which discovers what type of, what vendor, what OS, and then we execute commands to then pull information out of that device, and we derive that down into the grid below. So you can see here, all these devices have completed discovery. Gluware is very scalable. We can install multiple provisioning engines to actually hit more than 10,000 devices in under an hour. So certainly scale is not an issue for us. But what you see here is we pulled in an inventory, and we pulled in operating system version and SKUs and serial number, and even the uptime stat running on those devices. And this gives us a real-time inventory and what is actually running. A customer of ours recently added in roughly 600 switches into Gluware and found they're running close to 70 different operating system versions. When you have inconsistency of your OS version, you're going to have inconsistent bugs you're exposed to. You may have inconsistent features or commands that, if the syntax changes, which it does sometimes. So you're gonna kind of run into those issues operationally, and you're certainly going to be exposed. One other key feature I want to highlight here is within Device Explorer is we have integrated APIs with Cisco, and let me cancel here. Let me run it. Sorry, I was going to just do a Control A for all and say update support data. So I've already configured Gluware with the administrative tasks, including API access to Cisco, which all of our customers can enable as long as you have one valid SmartNet contract. What we're pulling in from Cisco is end-of-life, end-of-sale information, the SmartNet contract status, and the PCERT status as well. So if I double-click on any one of these, I can look at those details and see, right now there's no end-of-life bulletin issued. There is no SmartNet contract on this. This happens to be a virtual router, so it's just covered by that. And the most important one here is the advisories. So here we're pulling the Cisco PCERTs that have been issued and are exposed in the operating system or hardware that I'm running. If I double click in on this, I can read it, and I can see if there's anything that applies to my network. And so, just scanning this, malicious HTTP requests, this can be dealt with from a configuration standpoint. So what I might decide to do is, instead of executing an OS upgrade, if I've disabled HTTP services, I potentially can work around this issue. So let's move on. I will come back to that, but I just want to highlight Device Manager and real-time inventory and assessment. Let's jump into Drift and Audit. And what you see here again is the list of devices. With these devices, I'm going to execute a capture of all their config files. So again, Gluware is going out, it's interrogating the device, and it's going to pull the current copy of the configuration. That initial capture, because these devices were just added to the system, becomes the baseline to compare. So Julie's on the call with me. I'm going to ask Julie to access one of these nodes and go make an unauthorized change. Julie, once you've completed that, please let me know and I will rerun my capture. This is the piece that operations loves, which is, you can do this on demand and you can do this scheduled, and you have visibility across all your network nodes of what is changing. And again, most of our customers do run it on a regular basis. Julie, I don't know if you can confirm you made that change or not.
Yeah, sorry, Mike, I made a change.
Cool. So I'm going to execute a new capture, start the capture, and again, Gluware is going to interrogate those systems again and just pull their configurations. And it's looking for change. Obviously, that is what we want to know is over time what has changed. If things were working on Friday, not working on Monday, people are saying, oh, fingers begin pointing. I can see there's a change here on spoke 1. All I do is double click in and I see a side-by-side capture, and I can see two changes were made. So there has been a name server added, so someone added 8.8.4.4. If I look at the next change, someone removed the NTP server. So as I mentioned, config drift and audit is read only, but I'm going to tie this into, as we get to config modeling, what we need there in terms of remediation. So let's hit the second point here, which is audit. Audit's a hot topic, and I'll just touch on a more complex audit, which is the DoD STIG, which is about security. And so it's got all these guidelines on things you should do, like have inbound access lists. So I'm browsing the policy here. You should disable these services. I mentioned before disabling HTTP services. That's part of the standard. So what you're seeing here is a policy in Gluware that is defined with standard CLI commands and regex, and it also has the ability to scope. So if we want to ask the engine to look at this config on every interface, we can do that. So the one I want to tie in here is the standard globals audit. This is like your own company policy. Like I require a banner, I require name server, I require NTP, I require SNMP. And what I'll do is select the nodes here, select these iOS devices, and execute a audit. And again, I can run this on demand or scheduled. I'm going to run the standard globals audit and hit start. View results. We're leveraging the capture that's already there. So one node violated my policy, and actually it was related to that unauthorized change that was made. We actually have a violation because we require an NTP server, and it's not there. So Gluware can actually catch things in two ways. One is through drift, where you're just looking at what changed, and audit, where you're looking for something very specific. So moving on, and again, I'm a bit short on time, so I'm kind of pressing as fast as I can here to get through this content. When you look at Gluware's approach to configuration management, we use a technology called config modeling. Config modeling enables us to break down a monolithic config file into digestible components that we generically call features. So in this example, I'm automating banner, DNS, NTP, SNMP, and syslog. And again, this is a kind of bring your own policy type of design. So when I look into how we're teaching our engine what to write, here's the statement, right? We support static CLI. Here's the DNS. And again, we can have static defined IPs, or we can have variables. Certainly we're able to poke holes in the static blocks CLI. And what I just want to show you here is that we are teaching our engine what to write and how to read, because the read part is very important. So I am going to take this spoke one router here, which just was affected by that change, and I'm going to say I want to provision or re-provision all these features, essentially remediating this node because it has been edited. But instead of actually executing it, I want to do a preview, which is Gluware, tell me what you're going to do before you do it. And this is something people complain about with automation, is how do you validate it? How do you test it? Well, with Gluware, you execute a preview. You can dive into the logs. I'm going to expand my browser a little bit, make it a little clearer to see, Gluware, you see very detailed logs about what the Gluware engine is doing. But the view I like the best is the CLI view, where you're literally seeing what Gluware is doing on the CLI. When you click processed, you're able to see the exact changes that Gluware is going to do. So for features that are already configured correctly, our engine does nothing. For DNS, we know that was just edited. It's going to restore the proper one. It's going to re-add in the NTP server. Then there's some cleanup on syslog it needs to do. So this is what declarative provisioning is all about. And this is a preview. So I can actually append this to a ticket and get approval and then push this to the network. But using Gluware, the goal of Gluware as a system is to keep your network in policy. So as I look at these devices, I'm managing all these features, and I want to keep these features provisioned. So we're, again, quite short on time, but I want to show you one more thing before I turn it over to Julie for the NAC demo, and that's a brand new feature we introduced called the model discovery. So let me get logged in here. We're not going to be able to hit state assessment due to time, but I do want to show you model discovery. So in this system here, in the model editor, I just showed you one that was already built. Let me close this. Assessment, sorry. I have to skip the state assessment demo, and I'm going to jump right into showing you that in this particular system, there's nothing in there. There's no nodes, there's no features. The so-called things that Gluware is automating, it's empty. What we're able to do is through a new capability in 3.6 is execute a workflow. I talked about workflows. One of the categories of workflows are design. And with workflows, we can point Gluware at a reference node. So we can say, hey, Gluware, connect to this node. And let me, so connect to this node. And what it's going to perform is an assessment. It's going to look at the configuration. And as I was showing you before, Gluware has the ability to read each feature configured. Well, in this case, it's not only going to read it, it's going to pull in the configuration into the Gluware constructs. We happen to use JSON-based data modeling. It's recognized all these features and it's pulled them in. So it sees we have banner configured and NTP configured and QoS configured and security features, which are actually ACLs and interfaces. So you can see it discovered all these features. When I hit finish, Gluware is going to create those building blocks so that you can reuse them for automation. So when I go to workflows and I navigate back over to my model editor where I'm going to use config modeling and implement that automation, what I can see is in a system I had nothing there before. If I look at this reference node configured and I bring up my map, what I can show you is that on the fly, Gluware has created the assembly, which is like the shopping cart of all the features we're managing. And there's banner and NTP and QoS and security features as a group, SNMP, syslog. So Gluware can actually read in these features from a reference device to get you automated very, very quickly. So I'm going to skip this setup slide on NAC and throw it to Julie a little quicker than we planned, just so we can show you that demo. But what we want to get to is that Gluware can do a lot of functions and even automate things as complex as deploying network administration control on switch ports. So let me hit stop. Julie, if you don't mind sharing your instance and make sure your audio is on.
Yeah, can you see my screen?
Yep.
Yeah, okay.
We're good. Good to go. Thank you.
Great. Okay, so I'm going to jump right into config modeling. So that is the right feature. So everything's already been read in from the devices. The model's been built, everything that Mike described. And we're going to go specifically on this NAC use case. What I've highlighted here, or the concept here really is that you have to do a NAC rollout to all your devices. You've already figured out your policies. You've got this list of commands, and now you've got to get them on all your edge switches in an automated fashion. So this is going to show you how to do that. So I've homed in here on a particular switch stack. Highlighted in blue, there's an assembly attached to it. And again, there's only one assembly because I'm focused only on NAC. You could certainly add additional features to that assembly. I wanted to highlight a couple of things here as you're looking at this assembly. Is there's two things here. There's this global line of reasoning here, and what this is any commands that you would need to put on the entire switch stack. And then there are interface specific, port specific commands. So we are going to dig into all of that. Let me start with a global command, and in this case, for this particular example and instance, and this is pulled from a real configuration, there's only one global command that's required on the entire switch stack, and that's to turn on .1x. So we have this command set here. When it's applied, it will turn it on to the entire switch stack. If we go back to the switch stack, we can look at the interface version, this higher line here is my logic. And if you notice, there's the graphical on the left, and then there's the configuration on the right. So they should map together. So what you're seeing here is something called a switch port map, and it's tied to, again, to the interfaces. So I'm going to go ahead and dig into that, and you'll see on this particular switch stack, I have 2 switches defined to it. And both of them have the same configuration. They could be different. You could have a 48 port switch and a 24 port switch, for instance, and other things that are different. So let me go ahead and dig in deeper into a particular switch. And you'll see the port map is showing there are 24 ports built into the switch. So that's shown here. There are no uplinks. There's a module, a 4-port module. So what we can do, we also have something tied to this, and this is a group. And this group contains a bunch of lists of commands. So this group, again, we're only focused on NAC. You could add other groups, but we're only focused on the commands for NAC. So that's shown here. And if you look at the bottom of the ports here, I've applied that to all 24 ports. If you needed to, you could just pick 16. So the idea, again, is to take this whole group of lists of commands and apply it to these ports on each interface. Now let me check the module. Like we look at the module that has the 4 ports on it that's attached to this switch. You can see it's got the exact same group here applied, but there's nothing applied to the ports. So when I run the commands, nothing's going to happen to those ports. It's only going to be the 24 on the switch. So let's go down deeper into this group. And again, this is a group of lists of commands. So we're in the group. Here's our list of commands that we want to apply to the NAC interface. And you'll notice a couple of conditionals here. So not only do we have this list of commands that we're going to look at that's going to be applied to each interface, but we have this condition here that says whatever's in this list of commands, I'm only going to apply it and render it to the switch if it's one of these 4 commands. So if there's anything else in that list, I'm not going to apply it. I want to make sure it's only these 4 that's going on the switch. The second one is using information that we've discovered from the config, and we know whether the port is an access port, access mode port, or a trunk port. And so we're saying we're only going to apply this list of commands if it's an access port. Otherwise, we're not going to apply it. So now let's go ahead and look at the commands. So here we have, you can see interface, authentication, .1x, we have all the things that were listed on the other page, so we don't have any of these that would not be applied based on that condition. But we do have a couple of variables here. The first one here is showing switch port name. So for instance, gigabit Ethernet 101, gigabit Ethernet 102, etc. So it's going to be able to apply these commands and apply the right interface name for each interface that those conditions apply to. Secondly, we have another variable here that shows the VLAN. So we've discovered the VLAN. We know what VLAN is applied to this particular access port, to this particular interface. And in this command, we're going to use that information that we know for this interface and make sure it's part of this command. So you can see that's pretty powerful, all the information that's contained therein. So what I'm going to go ahead and do, and this is something you might do in a lab as well, you've got this specific NAC commands, you've got everything set up, and then you want to go ahead and see, well, what will that look like when I provision it on the switch? So as Mike showed you earlier, we can go to provisioning. We can go ahead and provision the switch, but I'm going to do the preview. That's always the safest thing to do the first time. And then I'm going to run the preview and show you what's going on here. And I've run it multiple times. So you can see here now I'm doing the event log. You can see it's checking, doing some pre-checks, and then it's going to start looking for those conditions on each interface and start mapping the commands. If you prefer, you can look at the CLI mode and see what's going on the switch via CLI. So we're going to let that run. It usually takes a minute or so to do. Again, we're doing 48 interfaces conditionally. So it's running pretty quick. All right, log out. So it's done. So let's look and see if we look at this is the raw information. If we look at the process information, this shows us exactly what would be put on the switch if we provisioned it. And you can see here the global command, the .1x has been applied to the switch stack. You can see the interface commands. Again, you've got gigabit Ethernet 101, you've got 102, etc. You can see the VLAN was applied. In this case, VLAN 100 was what was on this particular interface. And then if you look down here, if you look at port 104, you can see, well, these commands were not put on it. The reason why they were not put on it is because there were already authentication commands tied to this particular interface. What you do see here is that it had a different VLAN, and we're saying we want to use the interface, we want to use the VLAN that's on that interface. So it's actually going to correct that command, but it doesn't have to apply the other ones because they're already on it. So then the next thing you do is go ahead and do a provision, and I've already done that. In the essence of time, I'm going to go over. A good thing to do is to go look at your drift and audit to go ahead and see what's going on. So I've done a provision previously. And I captured the before, and I've captured right after I issued those commands just to show you this. And if you see, there's 41 things that were changed on that switch stack in a matter of a minute or two. So there's your .1x, there's your authentication commands, etc. You can see here it's changed the VLAN number. So if you can imagine, if you had to do this for a campus, of hundreds of switches, just how fast this would happen as you apply this assembly to all your switches and just let it run. So Mike, with that, I'm going to hand this back over to you to take Q&A.
Okay, excellent. Thank you very much, Julie. Let me go ahead and share the last two slides. Just a very quick summary. And what we want to highlight here, and hopefully you're seeing the screen, full screen, is that when you look across the spectrum of the applications, and at this point, we didn't get to highlight for you the OS manager in terms of doing OS upgrades or workflows. We showed you kind of one workflow from a design standpoint, helping you to accelerate your automation faster, but we're really just scratching the surface, and we felt like the NAC use case of a very challenging things to automate, if you're going to try to script that or you look at vendor tools out there, very, very hard. So Gluware is able to reduce that risk. Again, the preview is a key functionality, enhance security by auditing, compliance, implement security policies. It's about simplifying compliance in terms of keeping the networking compliant, which is, again, monitoring it for drift and audit daily, if not twice daily, or whatever the pace you need to. Gluware helps to eliminate those manual errors completely, can do proactive detection with the drift, and it brings agility and really a force multiplier when you're looking at making these changes across large networks. So with that, we have a couple minutes left. Want to try to address some of the questions that were raised. So one question, and again, you can submit questions in the Q&A there. I will look through them here. One question is related to authentication into Gluware. What does Gluware support? Gluware has native radius built in. If you're using that feature, you administer your users in the Gluware system itself. And there's 5 different levels of role-based access control. Gluware also supports external LDAP or radius. So if the customer is providing those features, we can hook into that, and your users are authenticated via those mechanisms. Second, a question here is, are Huawei devices supported? And the answer is no, not yet, primarily because our customer base has primarily been within North America. We were certainly able to onboard vendors quickly. So if we have a customer requirement or request, and I'll just give you a few examples, that we had the Blue Coat SG proxy device requested recently, and within 2 weeks, we delivered that. We recently onboarded Checkpoint. So we're able to onboard vendors quite quickly because they generally fall into kind of like the Cisco-like CLI or the Juniper-like more transactional CLI, and we're able to adopt those very quickly into our engine. And again, we're at 21 and counting operating systems that we support today. So a question on what do we do for firewall management? And that's a great question. It's certainly an area we're getting deeper and deeper to every day. Really, the answer is it depends. It depends on what the vendor provides support through the CLI, or if they control policies in a different way. Today, with platforms like the ASA, you have full control of those things. With other vendors, we can configure globals and things through CLI, and you may do your policy rules separately. So really the answer on that one is it depends. Looks like we have time for a couple more here. Do we back up configurations? Great question. Yes, and what you saw when we execute discovery, we always capture the latest configuration, and that is downloadable from the system. Also, when you look at drift, you have a full historical capture. And what's interesting about that is you can go and download any of those old configurations, but you can also compare old configurations. So one use case we had it for a customer was they wanted to compare configuration beginning of a quarter versus end of a quarter, so they can document what changes went into the network during that quarter. So yes, you get the configuration backup, and you get you have the full historical view of all those captures. So related to that, can we restore the configuration? So our approach towards the writing is to apply our config modeling. So those features that you have in your configuration are essentially imported, like I showed you with model discovery or built, and then you're able to restore or those features at any point very quickly and easily. And there was another question about scale. I'll just answer it in general, is that Gluware is a highly scalable system. There's one primary orchestration server that's installed, and you can have a second backup orchestration server. But the piece that's doing the work, kind of talking down all the nodes, we refer to as the provisioning engine. And so by default, a single install of the Gluware orchestrator has 2 provisioning engines, each capable of up to 50 concurrent sessions. But when you have scale needs, like we have customers, I mentioned Merck and Mastercard running at tens of thousands of devices, you can scale by installing additional provisioning engines, and then the Gluware primary orchestrator distributes those jobs to those engines, and also has queue management. So an OS upgrade is a longer job than drift detection, for example. But the answer is yes, the system is highly scalable and reliable. And then one other question was regarding logs. Hopefully we answered that for you. We do keep very, very detailed logs, not only of the Gluware internal messages, but of all the interaction with the device on the CLI. And that detail is stored at the most detailed level. So you just filter your view in terms of what you want to see. But one customer said that was like highly valuable, because in other systems, you are predetermining a logging level. And so you only see that log. And if you need more of a debug, you got to rerun it with debug on. And with Gluware, you get the details are always available. So with that, I'd like to ask you to take a couple actions. One is, if you like what you saw and you want to test drive it or kick the tires a little bit, we offer an online system. Many of the things I showed you are on that same system. So you can do an inventory and drift and audit and config modeling through test drive. So gluware.com/test-drive. Also, if there's something that you didn't see or hear and you'd like to dig further into your specific use cases or challenges, please contact sales@gluware.com or go to our webpage and just click request a demo, and we will set up a meeting, do some discovery with you, understand your challenges, and show you the Gluware platform, how it can help address your automation challenges. So with that, again, thank you very much for attending. We appreciate it. Please stay tuned for the next session we're planning for December on OS Manager. That concludes our session for today. Thanks very much.